Hi guys, so welcome back to our channel. Now this time we'll be discussing about applying multiplication and division on rational algebraic expression. Now, there are only two things that we need to remember when we are multiplying or dividing rational algebraic expression. We can take the process of multiplying and dividing of rational algebraic expression in a way on how we multiply and divide arithmetic fractions. Remember, in a multiplication of arithmetic fraction, we just need to multiply numerator to numerator and denominator to denominator, and then we can have the product of NM all over the product of DC. Now, in division of arithmetic fraction, the first thing that we need to do is to get the reciprocal of one of the fractions so that we can convert the operation. Instead of having a division, we can now have a multiplication and the reciprocal of the second fraction. And do the same thing when the multiplication of arithmetic fraction, the numerator, denominator to denominator. Now, then the product and the final answer will be the product of NC over DN. I have here some examples of applying multiplication and division on a rational fraction. Now, let's go ahead and try example number 1. Now, before we multiply numerator to numerator and denominator to denominator, in our previous lesson, we were able to simplify rational algebraic expression. In this case, we can start simplifying our rational algebraic expression before we can apply the indicated operations. We can start cancel out their common factors, their GCF, so that the moment we apply the multiplication or division, we will not be dealing with the larger values. Okay? Now, let's try to answer example number 1. Now, we have 11ab squared over 2c times 10c over 33ab. Okay, now the first thing that we need to do is to cancel their common factors. Now, let's look at common factor of 11, which is 33. 11 and 33 has a common factor of 11, so we can start dividing them. So 11, so we can cancel this. This will become 1. And followed by 33, if we cancel this will become 3. Now, next, we also have 2 and 10 also have a common, so we can cancel this. Their common is 2. So 2 divided by 2, this will become 1. 10 divided by 2 will be 5. Now, we're done with the numerical coefficients. Let's go on and try to cancel out some of the variables there. We have a here and also a, so we can cancel this. That will become 1, followed by b squared. So we can cancel b here, also the b here. This will become 1, but this one will be left with b, followed by c. We cancel c and c, which is 1. And the next step that we need to do is to write all of the remaining terms here, and we can start multiplying. So here we have 1 times b, that's b, all over 1 times, here we have 5 over 3. And you multiply numerator to numerator, denominator to denominator. So b times 5 is 5b, all over 1 times 3 is 3. So therefore, the final answer for number 1 is 5b over 3. That's the reason why we need to cancel the common factors first before we apply, so that the moment we do the multiplication or division, it will give us already the simplified form of the rational algebraic expression. So there's no need for us to do the simplifying after applying the multiplication. The final answer will already be simplified. Now, let's go ahead and try example number 2. For example number 2, just like what I mentioned earlier, there's a need for us to get the reciprocal of the second fraction so that we can convert our operation into multiplication. Now, the first thing that we need to do here is to get the reciprocal. To get the reciprocal of the second fraction, you just need to get the reciprocal of this, and we can now convert the operation into multiplication. So we just rewrite this 14m cubed all over 12nt. We can convert our operation into multiplication times 6n cubed p all over 7n. Okay, now the same thing that we did in example number 1, we can start canceling all of the common terms. So 14 and 7, they are common in terms of 7. So we can cancel this. This will become 2, followed by m cubed. We also have m here, so this will become m squared, and this will become 1. Next, we have 12 and 6. They are common terms of 12, so this will become 1, and this will become 2. Followed by n cubed and n. So we have n squared here, followed by p. So we can cancel the p because p divided by p is still p. Okay? And the next step that we need to do is to rewrite whatever left there, and we can start multiplying. So from here, we have 2m. So we have 2m squared all over 2 times n squared. That's n squared all over 1. Then multiply 2m squared times n squared. That's 2m squared n squared all over 2. But remember, we can still simplify 2 over 2 here. So 2 divided by 2, so we can cancel this. It's equal to m squared n squared. And that will become your final answer. Now let's go ahead and try example number 3 and number 4. So let's focus first on number 3. The operation involved here is multiplication. So same process. Now this time we're no longer dealing with binomials, but we have a binomial here. So there's a need for us to factor out. Remember, before we simplify, we need to make sure that our polynomials or rational algebraic expression is written in their greatest common monomial factors or in their factored form. For number 3, 2a squared plus 6, their common factor is 3 times the remaining factor is a squared plus, their common factor is 2, sorry. Common factor is 2, and we have a squared plus 3. All over this 5b cubed is already factored out, so there's no need for us to factor that, times the same with 10b4, we just need to copy that, all over. Now for this part, their common factor of 3 and 9 is 3, so we can remove their GCF and we get the remaining factor, which is a squared plus 3. Upon ensuring that all of the algebraic expression is already written in a standard form, in the factored form, we can now start canceling their common factors. The common factors we have is a squared plus 3, so we can cancel this and this one. Followed by 5, we can cancel them. This will become 2. And b raised to the power of 4 and b cubed, we can cancel this. This will be left with b. As you can observe, there's nothing left for us to cancel. And the next step that we need to do is to write whatever is left here. So this one, we have here 1. So that's 2 over 1 times, let's rewrite 2b. That's 2b all over 3. Then we can now multiply 2 times 2b. That's 4b all over 3. And that will become your final answer. Now, let's go ahead and try example number 4. For example number 4, still the same process, but this time this is division. Therefore, there's a need for us to get the reciprocal of the second fraction to convert our operation to multiplication. So we just need to rewrite that. V squared minus 9 all over 3v squared plus 12 times, we can now convert it to a multiplication and get the reciprocal v squared plus 4 all over v plus 3. Now, so the same process with what we did to the first one, we just need to get the factored form or the GCF form of the rational expressions. We can get the factor of v squared minus 9, that's a difference of 2 squares. So we can have v plus 9, v plus 3. So the factor of v squared minus 9 is v plus 3 times v minus 3 all over. Now, the common of the denominator is 3. They are common in terms of 3. So we can get their GCF, which is 3. And the remaining factor would be v squared plus 12 divided by 3 is 4 times v raised to the power of 2 plus 4. They don't have any common factors, so we can just simply bring down them. V squared plus 4 all over v plus 3. And again, after we write all of them into its factored form, we can now start canceling their common factors. So we have v plus 3 here. We can cancel v plus 3 followed by v squared plus 4. We can cancel that. And yeah, there's no other common factors that we can cancel. So we just need to rewrite everything, whatever left here. So we have v minus 3 all over 3 times, that's, since we're able to cancel everything here, so that will become 1 is equal to, therefore the final answer for this is v minus 3 all over 3. Then let's box our final answer. Yeah, that's it. Again, in multiplication and division of a rational algebraic expression is the same how we deal with arithmetic fraction. We just need to multiply numerator to numerator, denominator to denominator. If the operation is division, the only thing that we need to do is to get the reciprocal of the second fraction. Then we can now convert our operation into multiplication and do the same thing. And again, before we apply our operation, we need to make sure that we're able to cancel or remove all of the common factors so that the moment we do the multiplication, we will not be dealing with bigger values. And I hope you're able to learn how to multiply or divide rational algebraic expression, and I'll see you to the next tutorial.